welcome back to my channel. In today's video, I'm going to be doing an intro to absolute value equations and inequalities. So the definition of absolute value is simply the distance a point is from the origin on a number line. So with this distance, you ignore negative signs and positive signs. You just look at the pure distance, which is always going to be positive. So I'll make a note, it's always positive right here. So given that it's always positive, if you're given the absolute value of some number we'll call x equals some negative number, which we'll call y, this is going to have no solution. Again, because absolute value is always going to be positive, there's no way it can be equal to a negative number. So we're just going to cross this out and say this is wrong. Okay, so this is something to definitely keep in mind. Alright, so that being said, we'll go on to our first example. Right, so we're going to solve for x, given that the absolute value of x equals 4, right? So for this equation, I'm going to employ a number line to help us visualize this. So our origin, in other words, where the number line is 0, that's going to be our origin. And so we're going to go in both directions. We're going to go to the left and we're going to go to the right, and we're going to find the 2 points, or maybe there's even more points, where x is going to equal 4, right? So simply what we're doing is we're going to ignore negative signs and positive signs. We're just looking at a pure distance, right? So we're going to jump. We're going to have like little jumps that are going to represent our distance. So this is 1. This is going to be 2. This is going to be 3. And this is going to be 4, right? So in other words, this is 4 jumps or 4 units of distance away. So we know that x is going to equal 4 because it's 4 away from the origin. And now going to the other side, to the left side, we go -1, -2, -3, and one last jump to make it -4. Now, we don't look at the negative sign, we just look about how many jumps. So we had 1 jump, 2 jump, 3 jump, and 4 jumps. So this is the same unit of distance because we had 4 jumps. So x can also equal -4, so that we get a distance of 4. So we can also write this as x equals the plus or minus of 4. And so this would be the more proper way to write this answer. All right, so let's continue moving on. So let's solve for x, given that the absolute value of x plus 3 equals 4. Right, so using the last equation, whenever you have like any absolute value equation, whenever you get rid of these absolute value brackets, you can just set it equal to the plus or minus of any number. In this case, it's 4, right? And so we kind of just proved it in the last example. So from here, I usually split this up into 2 equations, right? So we have our 2 equations right here. So we have our 2 equations right here. So we have our positive version, so x plus 3 equals the positive 4. And we have our negative version over here, so x plus 3 equals -4. So from here, we can subtract 3 from both sides, so x is going to equal 1. And we can subtract 3 from over here as well, so x is going to equal a -7 value. Right, so these will be our 2 answers that satisfy this absolute value. Alright, so moving on to our next example, we're going to solve again for x, where absolute value of x minus 4 is going to equal 5. So again, whenever we get rid of the absolute value brackets, we're going to set it equal to the plus or minus of this number. In this case, it's 5. So from here, we can split it up into the 2 equations, the positive and negative version. So we'll use a different color. So we have x minus 4 equals positive 5. And x minus 4 equals -5. Right here, we're going to isolate our variable, so we're going to add 4 to both sides, so x is going to equal 9. And over here, we're also going to add 4 to both sides, so x is going to equal -1. And so x is going to be equal to -1 and 9, and these are the 2 values that satisfy the absolute value. All right, so let's continue on. So right here, we have solve for x, given that the absolute value of 2x minus 7 equals 9. Okay, so again, we're going to get rid of these brackets, and when we do so, we're going to have to set it equal to the positive and negative version of 9. So we have to account for both the positive and negative version. So we're going to split it up into two separate equations. Right here equals positive 9, and over here 2x minus 7 equals negative 9. All right. So we're going to isolate our variable, and we're going to move the constant negative 7 to the right side. So we're going to add 7 on both sides, and we get positive 16. We can divide 16 by 2 so that we get one of our answers as being 8. Similarly, we're going to isolate our x, so we're going to add 7 on both sides, so it's going to be a negative 2 value, and we divide both sides by 2, so x is going to equal negative 1. And that's going to be our two answers. All right, so let's do one last equation before we move on to our inequalities. So we're going to solve for x again, given that 12 minus 4x equals 16. All right, so let's remove the absolute value brackets and set everything equal to the plus or minus of 16. From here, we can split it into the negative version. So negative 16, and we have the positive version. So 12 minus 4x equals positive 16. Right here, we're going to isolate our variable. So for negative 4x, we're going to subtract 12 from both sides. So we get a positive 4. We're going to subtract, let's finish this one. So we divide everything by negative 4. So x is going to equal a negative 1. This is one of our answers. Now moving over here, we can subtract 12 from both sides. So we get negative 4x equals a negative 28. X is going to equal positive 7, and these are going to be our two values that satisfy the equation. All right, so now we are going to move on to inequalities. So absolute value inequalities can be solved very similarly to equations, but there are a few rules whenever you have like less than signs and greater than signs to keep in mind. And one of the big differences is that inequalities are ranges, not just individual answers, okay? Not just individual values. They're more of ranges where the equation is satisfied. So as kind of like an intro, we're going to solve for x, given that absolute value of x is greater than or equal to 6, right? So to kind of help us visualize this, as this is our first inequality problem, let's say we have our origin, which is 0, and we have the distance needs to be at least 6, right? So for x to be satisfied, it needs to be at least 6. So we have our positive 6 over here and our negative 6. Remember, these are going to be both 6 jumps. So remember our first problem. So this can be 1, 2, 3, 4, 5, 6 jumps. And this one as well. So 1, 2, 3, 4, 5, 6 jumps. And again, those jumps are always positive, so they're going to have the same distance of 6 away from the origin. Okay, so absolute value, we ignore the negative sign for right now. Okay, so what this tells me is that we want x to be greater than 6 jumps. So we don't want them to be only 6 jumps. We want them to be greater than 6 jumps, right? So we want x to be greater than 6, right? And we want x to be less than or equal to negative 6, because we just want to keep going this way, and we want to keep going this way, and we're inclusive. So we would write this answer as interval notation. We're going to go negative infinity to negative 6 inclusive union, because we're essentially uniting the two ranges, and we're saying it can be in this range or it can be in the range of 6 comma infinity, right? So we're saying or, basically it can be in either one of these ranges. So basically this answer goes for every single greater than problem. So in every single greater than problem, we can call this 6, let's just say 6 is a, right? So in every single greater than problem, we have a rule. So x is greater than a is going to be one range, define one range, and x is less than or equal to negative a is going to be the other range. So this is for greater than, and if you get this right, you're going to find your two ranges, and those are going to be your two answer choices, right? So this is how you do it, and this is the rule for all greater than inequalities. Right, so let's employ this rule in the next example. So let's say we have to solve for x, given the absolute value of x minus 5 is greater than or equal to 6. Right, so using our rule, we have two possible outcomes, right, for our two ranges, right? So we have x minus 5 is simply greater than or equal to 6, or we have x minus 5 is less than or equal to negative 6, right? Or like a negative a. So we're going to isolate our x, so we're going to add 5 to both sides, so x is greater than or equal to 11. And we are going to add 5 to both sides, so x is greater than or equal to negative 1. Okay, so to kind of better visualize this, we can use our number line right here. So we can create our interval notation. So let's say that this is negative 1, and this is 11 over here. So for this one, both of these points are going to be inclusive, and x is going to be equal to everything to the left, right? Because we want everything that is less than negative 1. And 11 is going to be inclusive as well, but we want everything that is greater than 11. Right, so for our interval notation, we have negative infinity to negative 1. That's inclusive. Or union, we can have everything from 11 to positive infinity right there. So this range, this collection of ranges are going to be our answer. All right, so now that we're confident with less than, we can move on. Or sorry, now that we're confident with greater than, we can move on to some less than problems. So let's solve for x given that 4x plus 12 is less than 10, right? So less than is a little bit different, right? So to remember the less than rule, I'll kind of write this. So less than, right? So we have kind of like a than and. And so when we're thinking about interval notation, you can refer back to my interval notation video, but when we're referring to interval notation, and usually signifies intersection, right? Which is represented by this. So this is intersection. This is a symbol for intersection. And so intersection basically is where we have two ranges and we want to see, well, what's in common, right? It's kind of like when you have an intersection on a street, it's like where the two roads meet. So we want to find like at what range, like at what points do the two ranges meet? And that's the intersection, right? So for this one, very, very similar. You're going to have two ranges again. So we're going to have our positive 4x plus 12 is less than 10. And we're going to have our negative where 4x plus 12 is greater than. So we flip the sign. So now it's greater than our negative 10. So all we have to do is solve for these two ranges. So we're going to isolate our variable. We're going to subtract 12 from both sides. We're going to divide both sides by 4. So we're going to get less than negative 0.5. We'll keep these as decimals and you'll see why right now. And so we're going to subtract 12 from both sides, sorry. So we have 4x greater than negative 22. And we're going to divide negative 22 by 4, right? So we're going to get a negative 5.5 from here. Right, so now, so we can properly see this and create our interval notation, we're going to graph this on the number line. So we have our negative 5.5 right here, and we have our positive, and we have our negative 0.5, which is our upper bound. So negative 5.5 is going to be non-inclusive, and it's going to be everything that's greater. So x is everything that's greater, so it's going to move to the right. And negative 0.5 is non-inclusive as well, but it's going to be everything that's less than, so we're going to move to the left side. Now, again, since our original equation, we'll use green. Since our original equation is less than, we want to find the intersection, right? The intersection of these two ranges. So we're going to look and we see what's in common, where these two overlap, and it's going to be this area right here. So to write our interval notation, our answer, we're going to have negative 5.5, but it's going to be non-inclusive, so we have parentheses, and it's going to go to negative 0.5, which is also non-inclusive. So this range right here is going to be our answer, right? Right, so let's continue moving on. So we have one more inequality. All right, so let's solve for x, where the absolute value of 3x plus 14 is less than or equal to 8, right? So the first thing that we want to do is we want to divide this into two equations. So we have our first equation, which is going to be 3x plus 14 is going to be less than or equal to 8. And we also have 3x plus 14 is going to be greater than or equal to negative 8. Remember to flip the sign and flip the change that into a negative 8. Right, so let's isolate our 3x. So we're going to subtract 14 from both sides. So we're going to get less than or equal to negative 6. And we divide negative 6 by 3. So we get x is less than or equal to negative 2. And this is our first range. So now to solve for our other range, we're going to subtract 14 from both sides. So we get 3x is greater than or equal to negative 22. And if we divide negative 22 by 3, we're going to get x is greater than or equal to negative 22 divided by 3. And this is an irrational number, so you can't simplify this further. Right, so now that we have our two ranges, we're actually going to plot this on a number line so we can see what's in common and create our intersection. So right here we have our lower bound, which is going to be negative 22 over 3, and our upper bound is going to be negative 2. Right, so for negative 22 over 3, this is going to be inclusive, so we do a closed circle. And it's going to be everything that is greater than, x is everything that is greater than negative 22 over 3. So we're going to draw our line going to the right side. And then concerning the x less than negative 22, x less than negative 2, negative 2 is going to be inclusive, and it's everything going to the left side because it's everything less than. So now all we have to do to finish off this problem is we just see, well, what's in common between these two, and we see the intersection right about here. And this is our intersection, right? So now for our interval notation, we just take our lower bound right here. We check, is it inclusive? Yes. And we take our upper bound, negative 2, I'm sorry, I keep saying negative 22. And we check, is it inclusive? And it is. So we add our bracket. And so this right here is going to be our answer. Alrighty guys. So that was the last problem. Thank you guys for watching. Make sure to check out my other videos under my Algebra 2 playlist. Make sure to subscribe, and thank you for watching.